Number 13, we have 3 times some stuff squared minus the number 15 equals 0. So there's no middle piece. So I don't have to worry about trying to factor this. We have trouble with that anyway. So I'm just going to simply move my number over here and add 15 to both sides. And I get 3 times what I'm trying to isolate. So we're trying to get this by itself equals 15. So now how do I get to b minus 4 squared by itself? Get rid of the multiplying by 3 by divide by 3. Divide by 3. So I get b minus 4. That quantity squared equals a 5. Now I need to undo this squaring. How do you undo a squaring? You take the square root. When I do the square root of a squared, it just makes it all disappear and I get just b minus 4. But since I took the square root of the left, I must take the square root of the right. And I must remember, if that had been like a 16, I would have had a plus 4 or minus 4. There's always the positive root and the negative. And in this case, 5 is not a perfect square, so I just got to leave it sort of square root of 5 until I can figure out what that is. I know it's like 2 point something because 2 times 2 is 4, so it's a little over, I'm going to guess 2.2, 2.3 maybe. I don't know. But the calculator will do it for us. Now, the next step, though, is I need to move this 4 over to that side to get b by itself. So I add 4, and we get b is equal to a plus or minus root 5, add 4. I now need to separate it into its two parts. I need to do the positive root 5 plus 4 and the negative root 5 plus 4. So I'm going to write it here. Positive root 5 plus 4, b is equal to the negative root 5 plus 4. I grab my calculator, I do square root of 5, I hit enter, I then add 4, and that gives me approximately, I'm going to go to the hundredths, 6.24. Grab my calculator again, I type in negative root 5, I hit enter, it gives me like negative 2.24 something, and then I add 4 to it, which then gives me to the hundredths about 1.76, and those are your two solutions to this equation for b's value up here, plugging in there, that would make this a true equation.